MSc Part 2, Semester 4, Paper 2, Synthetic Organic Chemistry 2. In that you need to design organic synthesis 2. Okay, the next point is the alkene synthesis. Firstly, by elimination from the alcohol and derivatives. The alkene means olefins can be synthesized by the dehydration of alcohol, usually under the acidic condition. The alcohol being made by the usual method. The acid must be fairly strong for this purpose and must have the non-nucleophilic counter ion, otherwise the substitution may occur. Unpopular ones, the KSHO4, crystalline and easier to handle than the H2SO4. So, and the phosphoric acid or less acidic is a POCl3 in pyridine. A double bond is inside the 6-membered ring is generally greatly preferred to one outside, and cis alkene is possible. For example, is the retrosynthetic analysis first, in that the FGI is a functional group interconversion. The firstly what happened, there is a dehydration. इथे काय होणार आहे, डिहायड्रेशन तिथे होणार आहे. ओके, सो काय होणार, आर आणि कार्बन मधला जो बॉन्ड आहे तो तिथे ब्रेक होणार आहे आणि फॉर्मेशन ऑफ दिस कीटोन ग्रुप इज अ 1 कार्बन कार्बन बॉन्ड इज ब्रेक डाउन and formation of this ketone group and plus RMGBr. So what the synthesis of this retrosynthetic analysis? The first is a ketone is a reacted with the Grignard reagent. RMGR means R is a negative charge, R is a negative nucleophile. So the nucleophile is attached to this carbonyl group, formation of this alcohol, and the last step is the dehydrogenation, removal of the H2 molecule. Then the another example is the retrosynthetic analysis. First is a PH double bond R, PH double bond R. The first is a functional group interconversion, the dehydration. So formation, there is alcohol and then this pH, both pH group is a cleaved out. Okay, so the one carbon carbon bond is cleaved and the formation of a 2 pH MgR Grignard reagent and this ester molecule. Then what is the synthesis? The firstly ester molecule is reacted with the pH MgBr. So ester molecule is a 2 pH MgR. So the first pH is attached to this ester, then removal of is a OET group and then formation of this ketone, and then again the pH group is attached to this ketone and the formation of the alcohol, and using the POCl3 and pyridine and formation of this alkene molecule. The elimination of alkyl halide follow the essentially the same strategy as the halide is usually made from the alcohol. For example, the retrosynthetic analysis, in that the first is the target molecule alkene, there is alkene. So the first is the FGI is a functional group interconversion, means elimination reaction. There is a bromine alkyl halide formation. Then again is a FGI is a functional group interconversion substitution. The Br is substituted by the OH group, and the 1,2 group 1,2 carbon carbon bond is a cleaved and the formation of the epoxide ring, and RMGBr is a Grignard reagent. The simple synthesis is the RMGBr is reacted with the epoxide ring and formation of this alcohol, and the PBr3 for Apple reaction there is a so the formation of this alkyl halide and the tertiary butoxide as a base, the abstract the H plus and the formation of this double bond, removal of Br molecule. Then by the Wittig reaction, the above the method is alkene synthesis have now largely been suppressed by the Wittig reaction, which gives the total control over the position of the double bond and the partial control over its geometry. And the following the mechanism of this Wittig reaction, the Wittig reagent is RCH2Br is a PPH3, then formation of this abduct, and then last step is a base BULI and Halide formation. In the mechanism the following: the firstly the Wittig reaction forms the sigma and pi bond, that is the double bond, and the reaction of the disconnection at the double bond nearly free the choice of the end, and comes the alkyl halide 1, and in which the from the carbonyl group compound 3 and the olefin, which is impossible to make the elimination to easily made by the either Wittig routes. A perhaps the easier cyclohexane easier than the handle the formamide. For the synthesis of the analysis, in that the first is a Wittig reaction, the alkene is a converted into the ketone. Okay, then PCH3 bond is a glued, so formation of this halide and PPH3, alkyl halide and PPH3. The synthesis route A, what is happening in this? The firstly is a PPH3 is reacted with this alkyl halide and formation of the halide, and then this halide is attached to the ketone and the formation of the alkene. The Wittig reaction is a well known reaction. So, in the last slide is a there is a mechanism of this Wittig reaction. So, you can try it, practice it. Okay, the stereochemistry in Wittig reaction, the general rules is that stabilized halides they react with the aldehyde to give the mainly E trans alkene, with the unsubstituted halide it gives the Z cis alkene. Then the next is the use of acetylene, means alkyne in organic synthesis. The acetylene itself is readily available, and the first important property is that the ability of to form the anion first, usually with the soda amide in a liquid ammonia, and also by the exchange with the Grignard reagent. This one, the firstly is a acetylene is reacted first is a NaNH2 and ammonia, then formation of this adduct, and then again this acetylene is reacted with the ETMG-Br is a Grignard reagent, formation of this adduct. The two adduct is formed. This is NaNH2 is act as a base, and also ETMG-Br is act as a base. So, the new few carbanions available as a genuine intermediate in the first is the anion 1 is reacted with the alkyl halide carbonyl compound and oxide to give the intermediate 2 and 4. So, this anion is reacted with Rx alkyl halide is formation of this acetylene. Then this acetylene is anion acetylene anion is reacted with carbonyl group in the formation of this acetylene also, and then again this formation of the epoxide, the formation of this acetyl molecule. These are the different ways the formation of the acetyl molecule. This product is a 2 and 4 still have the acetylene protons, so they can react with again with the base, and the electrophile to give the similar product is a 2 to give 5. There is alkynes is react with the NaNH2 and ammonia is the formation of this anion. The NaNH2 is act as a base, and this anion is reacted with this nucleophile is reacted with the carbonyl compound, the formation of the alcohol plus acetylene. The transcyclizer abolition 6 is the acetylene adduct and can be synthesized follows. The retrosynthesis of this reaction is the first is the target molecule is a 1,1 carbon-carbon bond dissociation, disconnection, and the formation of this ketone and synthon and reagent. Okay, these are the anion is a synthon and this acetylene molecule is a reagent. In this synthesis is simple. The acetylene is reacted with the NaNH2 and ammonia. They act as a base to abstract the proton from the acetylene, and this attack to the anion is a nucleophile is attacked to the MECOET, means ketone group, and the formation of this alcohol. Similarly, the deforming the surfactants surfenol the clearly acetylene adduct, and the synthesis is the straightforward. The synthetic analysis in that the first is a target molecule is glued by the carbon 1,1 carbon-carbon disconnection, and 2 moles of a ketone is a formation and alkyne. In the synthesis is the simple. The alkyne is reacted with the base, and this nucleophile is attacked to the ketone, and the formation of this alcohol and acetylene molecule is a triple bond is formed, and again is a acidic proton is there. So, the abstract to the base and the attack to this ketone, and there is also formation of this second is a alcohol and the formation of the alkyne formation. The some acetylene adduct are also valuable intermediate because the substituted acetylene can be reduced to sea salt transalkene. So, the desired, and because the monosubstituted acetylene can be hydrated to the ketone. The first is a R C triple bond C R is a alkyne, is reacted with the H2PD BaSO4 is a linear catalyst. The conversion is a cis alkene, and the NaNH2 used in this alkyne molecule the formation of the trans alkene. Okay, so these are the difference between the cis alkene and trans alkene using these two different reagent in this reaction. So then again is a RC double bond H R is a alkyne is reacted with H plus Hg2H2 is formation of the directly into ketone molecule. The important intermediate is cis butane diol can be made by the hydrogenation by the corresponding acetylene. The retrosynthetic analysis, the target molecule is firstly is FGI, means functional group interconversion. The reduction is there is a double bond is converted into the triple bond, and then again 1,1 carbon disconnection and formation of this aldehyde and the alkyne molecule. The synthesis is the simple. The firstly is the alkyne is reacted with the 2 moles of aldehyde, the formation of the alcohol molecule, and acetylene is a triple bond is remains, and then again linear catalyst is reacted to the alkyne, then the formation of the target molecule means cis alkene formation. Because of this, in above example, in this acetylene the use of the linear catalyst, the formation of the cis alkene, and use of the NaNH2, then formation of the trans alkene. Let us outline the synthesis of a bromide, which is the often used in synthesis of an important perfumery constituent is a cis jasmine. Is a retrosynthetic is a firstly is a FGI conversion. So the A and B is a bond breakdown and the formation of this alkyne and ATBR. Then synthesis is that the BUL is reacted with its acidic proton formation of the anion to attack to the ETBR, and the formation of this intermediate, and PBr3 formation of this target molecule is a acetylene triple bond. Okay, either the deconnection of the A or B could be used as a synthesis. The dianion is alkylate at the carbon because of the carbanion is a pK is acetylene is a 25, the much more reactive than the oxyanilisation. The alcohol 16, the protonation of the alcohol is necessary. So the dianion synthesis is the acetylene are the particularly useful for the synthesis of a diene of type the double bond bit outside the ring. So the comes from the acetylene, and that inside the ring from the dihydrogen the alcohol, and hence this acetylene is a reagent of the vinyl and synthon. The hydration is the triple bond between the Ag2 with the Ag2. So catalysis depend upon the forming the more stable vinyl cation. Hence the terminal acetylene always give the metal ketones, and the cartesian perfume can be made by this way. So the firstly is a conjugated alkene move easily without metal catalyst, the michelation water to give the 3 diketone pH C triple bond C ketone. There is H plus H2, the formation of this diketone, and other type of the acetylene adduct is a 3 and 4 can also be hydrated. For example, there is a OH and triple bond. So the Ag2 is reacted with this triple bond, the formation of this ketone, and the cyclic compound the dehydrated in the ring as well as the hydrated in the side chain. So this also alpha beta unsaturated compound is formed. Alpha beta unsaturated ketone is also formed. Thank you.